periodic table of elements. Okay, and the periodic table in your textbook on page 18 and 19 gives you a lot of information. What do those Roman numerals with the letter A on them mean? Do you remember? They represent the valence electrons in any atom of that group. So all of the elements in group 1A have how many valence electrons? They've got one valence electron, right? How many valence electrons do the elements in group 15 have of your periodic table? They have 5 valence electrons. There's a Roman numeral 5 there. When we talk about Lewis notation involves simply writing out the symbol of that element. So if I took nitrogen for an example, okay, nitrogen is N, right? Is everybody with me on that? Yeah. Now, Lewis notation implies that you are going to use a dot system to represent how many valence electrons nitrogen has. What group is nitrogen in terms of its valence electrons? It's in group 15, but it has how many valence electrons? 5. Therefore, Lewis notation will have 1, 2, 3, 4, 5 dots. 1 dot for every valence electron. Okay? What would chlorine have? Cl. It would have 7 dots, right? 1, 2, 3, 4, 5, 6, 7. Okay? 2 on the north, 2 on the south, 2 on the east, 2 on the west is a full valence shell. So if I tell you that there is an element with 8 with a Lewis notation of 8 in period 4, what element am I talking about? If it has a Lewis notation of 8 and it's in period 4, look at your periodic table. I am talking about krypton. So how would I draw this? What would I draw? What element, what symbol would I put down there? I would put Kr and then what? 8 dots. Where would my dots go? 1, 2, 3, 4, 5, 6, 7, 8. Now, Lewis notation is going to be nice and helpful later on when we start combining elements. Okay? If I say, I'm getting ahead of myself, I know this. Okay, but humor me. Okay? If I say that I've got sodium and chlorine that combine to form table salt, which is sodium chloride, I can show how that actual molecule gets formed in terms of giving and taking electrons by drawing out their Lewis structures. What group is sodium in? It is in group 1. What does that mean in terms of valence electrons? It's going to have 1 valence electron. So Na is going to have, and I'm going to draw a little circle here. That is its 1 valence electron. How many valence electrons does chlorine have? It's going to have 7. So if I draw Cl over here, I'm going to draw little X's. 1, 2, 3, 4, 5, 6, and 7. If I want to show how these guys actually combine to form a molecule, I can do that using Lewis notation, because what ends up happening here is the chlorine comes in and it takes sodium's 1 electron to fill its shell, right? That forms a molecule. It's just an easier way of drawing the valence electrons on any atom. And Lewis notation, you will always have a periodic table that will always tell you the Roman numerals of the groups that have valence electrons. So this is really easy in that you look at whatever symbol is there and you draw out only the valence electrons it has. And mark my words, some of you will do this. Okay, some of you will actually, if I ask you to draw chlorine, you will look at the periodic table and you will say Cl. Okay, well, Cl has an atomic number of 17, means it's got 17 protons. Okay, so it's going to have 17 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17. Yeah, Lewis notation. No, this is not Lewis notation. I don't even know what that is. That's a Cl with a bunch of X's around it. Lewis notation is only a representation of what? Valence electrons. Okay, that's the only thing that goes around those actual elements. And is anybody here still confused by where to find the number of valence electrons that any substance has? Awesome. Thank you for being honest. Let's go over that one more time. If I look at the periodic table, there's so much information here that you have access to that you don't have to memorize. But it does no good if you don't know where to look for it, right? It's useless. So let's make sure that we know where all the possible information on this periodic table is for you. When we're talking about valence electrons, we're not even, and I'm going to make my line thickness nice and big here, and I'm going to be like, this does not exist in terms of our valence electrons. See you later, suckers. Okay, it was nice knowing you. Now, here we go. Look, oh, it's gone. Nice. Now, valence electrons only deal with the Roman numerals that have little a's next to them. 1a is in group 1. 2a is group 2. We skip all the b's. Nobody cares about the b's. And we go over to 3a, which happens to be in group 13. If you scratch out the 1 in all these teen numbers, okay, if you forget that this is group 13, you will see that oh, look at that, it's got a 3 left. If you hide the 1, it's got a 3 left. That's how many valence electrons it has. Or you look at the Roman numerals and you say, oh, it's got 3 Roman numerals. It's got 3 valence electrons. Okay, the Roman numerals are right here. Always, always at the top. Okay? Always at the top. That's telling you how many valence electrons are in each of those groups. What is a group? Column. A group is a column, right? What is a period? It's a row. So, knowing this now, knowing where to find the valence electrons, do you think that you can do Lewis notation? Yes. Right? So if I looked at this and I said, okay, show me, go with silicon. What would you do for silicon? Okay, first of all, what is silicon's symbol? Si, right? Si. What group is silicon in? Nope. Here. What group is silicon in? 13. 14. What does that mean? 4 valence electrons. So if I look at this, it's in group 14. It's got Roman numerals 4a, 4 valence electrons, and I draw north, east, south, west. And then I go back up to north and work my way around the circle again. So in reality, if you had something like magnesium, which is Mg, what's the actual valence number for magnesium? 2. You could easily put 1, 2, and that's still right. Okay?